Okay, today we are looking at solving differential equations by separation of variables. This is a 5 to 6 point problem, usually shows up in the free response section. And I'll show you step by step where all the points come up. So this is some important stuff because it will show up on the AP exam. Alright, so what exactly is a differential equation? If you'll read there, it says it's an equation that involves x, y, and the derivative of y. That's the definition of a differential equation. Okay, we've actually solved differential equations before, except when we've done it before, it's usually just dy dx equals something that's in terms of x. Okay, today we're looking at stuff that's in the form of dy dx and has x and y mixed on the right side or left side or both. Okay, so that's the difference between differential equations we dealt with before and the differential equations we're doing today. Okay, and we are looking at, more specifically, a variables separable differential equation. Okay, and what do you think that means?
Separate the variables.
I can separate the variables. Okay, so that's what we're looking at today, and we're going to solve it by a strategy that's called separation of variables, which is pretty self-explanatory. Okay? So, that's a little background to what we're doing today. So we want to get started on this first one. We have the differential equation dy dx equals 2x over y. Okay? And we want to solve for y as a function of x. So what do you think we want to do to get started?
Separate the variables.
We want to separate the variables. So what does that mean, Harrison?
Not sure.
Not sure. Does anybody have an idea of what separate the variables entails?
I think
Do
that's
it
hard.
in the S.
Separating.
We want to separate them, but how do we want to separate them?
Split up into two.
You do 2x times 1 over y.
That's kind of separating them, but we want to go a little bit further than that.
Did you
Y.
do the X?
2x plus
Y over dx over.
We want to get the stuff that involves y and put it on the left, and we want the stuff that involves x and put it on the right. So that's how we want to separate. Y is on the left, x is on the right. So what am I going to do in this case to separate?
Multiply y dx.
Multiply by y, multiply by dx. So I have y dy equals 2x dx. That is where your first point comes from on these problems. Your first point is by separating. If you separate, you get the first point. Okay? Now, once I'm separated, what do you think we want to do?
Solve for y.
What do you mean solve?
dy by itself. dy by itself.
Get d by itself.
What do we usually do whenever we see dy or dx derivative?
Take a y or an x out.
I've already got, if I see dy dx, I've already taken the derivative. So you want to do which side?
Plug
Which side?
in.
I want to integrate. Very good, Chelsea. I want to integrate both sides. Okay, so what do I get when I integrate y?
Y squared.
Y squared over 2. What do I get when I integrate 2x?
X squared.
X squared. You picked up your second point there. What else do you think we need?
Y is over 2.
Oh, sorry. You're right. So we picked up our second point there. What do you think we need to do to get to the third point? What's something we usually do that we haven't done yet on this problem?
Get y by itself. I don't.
U.
What type of integral are we dealing with?
Plus c definitely.
Plus c. We need plus c to pick up the third point.
It's only on one side.
So we've got 3 points so far. All right. Pauline says we only need plus c on one side.
Yes, but c is always the same.
C is a constant. It doesn't matter what it looks like. So technically, you could put a plus c on the left and a plus c on the right. But when I put them together, what do two constants form?
C.
Another constant. So I only need one plus. I only need one plus c.
I still don't
All right. Now, at this point, we're going to go ahead and move down here to the second part. We want to go ahead and get y by itself, but we're going to move to the second part before we get y by itself. When you get y by itself and you don't have anything to plug in, what that's called is the general solution. Okay, but we want to go ahead and get the particular solution, and that occurs whenever they give me an initial condition. Okay, at this point, what do you think is something good to do before I plug those numbers in? To make it a little bit prettier, easier to work with. Multiply by 2. But again, a constant times 2 is just another constant, so we're still going to call it a constant. Bless you.
Oh, now I.
We're gonna find the constant later, yes. Okay, so far we've gotten 3 points. The 4th point comes from when I plug in my initial condition. So I'm going to plug in 3, which gives me 9 here. I'm going to plug in 1, which gives me 2 there. We have picked up our 4th point there by using the initial condition. So that means that C has to be 7. The final point comes from plugging C back in and getting Y by itself. Okay. Now notice there are 2 places where C is at. Make sure you plug it in to the same one you plugged in your initial condition. Okay, so since I plugged in 1 and 3 at this spot, make sure you plug your C back into this spot. If you plug it in to this first one, it's going to screw it up. You won't get it right. Okay, make sure you plug your C back in wherever you plug your initial condition. So I'm going to have y squared equals 2x squared plus 7. And I'm 1 step away from getting y by itself. What do I need to do to get y by itself? Take the square root. Now, when we do square root, what do we usually do as well? We usually do plus or minus, but we don't want plus or minus. We want the plus or the minus. We don't want both. So which one do I want on this problem and why?
Plus. Minus.
Why?
So I guess minus is right.
I don't know. You tell me.
I say plus.
You said plus. Why do you say plus?
Because there's not a minus on the whole
There's
thing.
a square.
The y I give you is negative.
Minus, you can't get a negative.
Okay.
The minus is the one we want.
Why? Because you can't get a negative out of the square root.
Right. When I plug x into this, I have to be able to get negative 3 out. But when I take a square root, what's the only only two types of numbers that can come out of the square root? Positives or
Imaginary.
0. Because 0 is not a positive or a negative. So a 0 can come out of the square root, a positive can come out. So if I want my answer to be negative, that tells me that I have to have a negative on the outside of my square root. Okay, so let's recap. Where do we get our 5 points from?
Separating.
Separating is point number 1.
Integrating.
Antiderivatives is point number 2.
Plus C.
Plus C is point number 3.
Plug in.
Plug in is point number 4. And the final answer where y is by itself is point number 5. Now sometimes these will be worth 6 points. And that comes because if they think the antiderivatives are somewhat difficult, they'll give you a point for each antiderivative. And that's where you get a 6 point. But in this case, neither one of those is considered hard, so you only get 1 point for both antiderivatives combined. All right, next one. On the back. We want to solve for y as a function of x. So I have y prime equals x squared times the square root of y, and the initial condition is y of 3 equals 4. So what do we do to get started?
Separate. Square root.
Separate.
Separate? How do you want to separate?
By the square root.
What?
So divide by the square root.
Divide by the square root. Now, this y prime, what does this y prime represent? dy over dx. Now, when I divide by the square root, don't do dy over the square root of y, because you guys have trouble understanding what that represents. Whenever you're dealing with this, you always want the 1 over the square root, and you always want the dy out to the side, because sometimes you'll confuse yourself if you put dy on the top. And on the other side, I've got to have x squared dx. So you picked up a point right there. Now we need to integrate both sides. So let's do the right side first. What do I get on the right side? X to the cube, x to the third divided by 3. Putting the plus c over there. What about the left side?
Y to negative 2y to the 1 half.
1 over 2 square roots of y times natural log y.
You just want us to
U, U.
Do you not change it to y to the negative 1 half?
I would change it to y to the negative 1 half and then integrate it. That is correct. So what do I get?
Isn't it
Is it
negative 2?
two?
Isn't it negative 2 y to the 1 half?
Negative
It's
is
y over 2
2
square roots of y.
y to the 1 half.
Should be 2 y to the 1 half is what we get. I can't hear you.
Well, I said a million times negative 2y to the 1 half. Normally
Yeah,
you
but there's
say-
no negative.
But normally you say you're close. I would have said okay too.
All right, how many points do I have?
2, 3.
3 points. Justice, where are my 3 points at?
You separated, then you get the antiderivative, and you added c.
Okay, separated, antiderivatives, and plus c. I've got 3 points. All right, now what do I want to do at this point?
Quit.
No.
Initial condition.
All right, before I do the initial condition, what do I recommend you do?
Divide by 2.
Get rid of the fraction, if possible. So what can I do to get rid of my fraction?
Multiply by 3.
Multiplied by 3. So let's make it 6y to the 1 half equals x cubed plus c. And now let's plug in the initial condition. So I'm going to end up with 12 on the left, and I'm going to end up with 27 on the right. So c equals negative 15. So I have 6y to the 1 half equals x cubed minus 15. So what do you want to do to continue? Get y by itself. How am I going to do that? Divide by 6. And square both sides. There it is. Now, what are 2 things that I should be able to do with that to make sure I did this correctly?
Take the derivative.
Take the derivative, and I should end up with what we started with. I should be able to plug in my x value and get a y value of 4. I should be able to plug in and get a y value of 4. So if I plug in 3, 3 cubed is 27, 27 minus 15 is 12, 12 divided by 6 is 2, and 2 squared is 4, which is what I was supposed to get. Okay? So that's a little check you can do to make sure you're doing things right. All right, one more. I have dy over dx equals 4x y squared, and my initial condition is y of 2 equals 1. So Alex, get me going on this one. Separate. What do you want to do to separate? What?
You divide by y squared.
Divide by y squared. So I would have 1 over y squared dy equals 4x dx. Very good, Rob. Now notice that I kept the coefficient of 4 on the right side. Always keep your coefficients on the right side. It can get confusing if you move the coefficients. So leave the coefficients on the right side. All right, now what do we want to do?
Integrate.
Integrate. So the right one is easy. What do I get when I integrate 4x? How much?
X squared. 2x squared.
2x squared. All right, what about the left side?
Negative
Negative.
1 over 1.
Negative 1 over y. Chelsea, how many points do I have?
3.
Where are they at?
You separated the integration and added the plus c.
Very good. All right, Kaylee, what's next?
Plug in the initial condition.
Plug in my initial condition. So I plug in 1, gives me negative 1 on the left. I plug in 2, gives me 8 plus c on the right. So we get negative 9 equals c. So I have negative 1 over y equals 2x squared minus 9. All right, Pauline, what do you suggest next?
Well, I was just gonna move the y over and then move all 2x squared minus 9 back that way.
So what does that look like?
Negative
Just
1
switch
over
y
2x
in the
squared
right.
minus 9.
That works for me. And we have solved. And what is that solution called?
Particular
We have found that particular solution.
Can you just flip both sides and then multiply by negative 1?
That's another way to do it as well. That is correct. So you can flip both sides and then move the negative over, you get the same answer. All right, so that is solving a differential equation using what method?
Separation of variables.
Separation of variable. All right, so what's step 1? Separate variables. Step 2,
Integrate.
integrate. Step 3,
Plus c.
plus c. Step 4,
General solution.
Plug in,
plug in your initial condition. Step 5,
get y by itself.
get y by itself. And if I end up with a square root, what do I need to make sure I do at the end?
Plus.
Choose positive or negative. I choose one of those two. Very good.